So we're going to start looking at the properties of exponents. Now, what we are doing here is we are multiplying two terms together, and they have the same base. So right here I have b to the nth power times b to the m power. What's important here is that you identify that what is being raised to the exponent is the same. Okay? If that base, if what's being raised to the exponent is not the same, then this property does not apply. So, when I have two terms multiplied together and their base is the same, I am going to add their exponents. I add their exponents when their base is the same. Okay, so I want to talk for a minute about what x to the 7th and x to the 8th mean. I want to talk about what it means. Okay, x to the 7th means that x is multiplied by itself 7 times. Okay, so I have x to the x to the x to the x, or I'm sorry, x times x times x times x times x times x times x. Is that 7 x's? 1, 2, 3, 4, 5, 6, 7. So it's x times x times x times x times x times x times x. That's x to the 7th. X to the 8th, okay, is x times 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 x. Okay, that's what x to the 7th and x to the 8th mean. Now, if I were to count all of these x's and write them with the same base, I would have x to the 15th power. So what I have done here is I've said x to the 7 plus 8. And x to the 7 plus 8 is x to the 15th. The operation that is happening here is multiplication. That's what's happening between the x to the 7th and the x to the 8th. It's multiplication. Okay? But the rule or the property tells us that when we're multiplying them together, we're able to add the exponents. Okay? Now let's do the next one. The next one has numbers in it, so we can actually figure out the values. So using this property, I've got 2 to the 3rd times 2 squared. So 2 to the 3rd times 2 squared is the same thing as 2 to the 3 plus 2. And there it is, our emergency siren. Okay, there is no tornado today. It's only really hot. So it shouldn't last too long. So 2 to the 3 plus 2 is 2 to the 5th. Can I figure out what 2 to the 5th is? Okay, it's 2 times 2 times 2 times 2 times 2. What is that? It's 32. Okay, it's 32. So the answer to this is 32. Now, I want us to look at it this way. I have 2 to the 3rd times 2 squared. I can figure out what 2 to the 3rd is. 2 times 2 times 2. What is that? 2 times 2 times 2. Good. Then I have 2 squared. What's 2 squared? 4. And 8 times 4 is 32. Okay? So it works. That's what's happening here. Okay? So that's our first property. And I definitely would highlight that property, and I would keep the list of properties close by as you're working on the homework. Okay, our next one is a power to a power property. Power to a power property. So what is happening here is I have an exponent with a base of b, and I am raising that to an exponent of m. Okay, so I am raising a power to another power. That's the power to a power property. And my rule, this property tells me that I multiply the exponents. That's what's happening here, is I multiply the exponents. Okay? So x to the fourth raised to the fifth power, what that means is I have x to the fourth multiplied times itself how many times? How many times am I multiplying x to the fourth times itself? 5 times. Now I'm multiplying x times itself 4 times right here. So what this means right here is x times x times x times x. Okay, so that's what that means. And that occurs 5 different times. Okay, now based on this property right here, I can add each one of these 4s together. So what's 4 plus 4 plus 4 plus 4 plus 4? 20. Do I get that if I multiply 4 times 5? Yes. So I can multiply the exponents together when I am raising them to a power. Okay? So here I've got one with numbers, 2 to the third, and I'm raising that to the second power. So this property tells me that that means it's 2 to the 3 times 2. Okay? 2 to the 3 times 2. That is 2 to the 6th. Can I figure out what 2 to the 6th is? It's 2 times 2 times 2 times 2 times 2 times 2. It is 64. Okay, so 2 to the 6th power is 64. Now, here I've got 2 to the third, and I'm going to raise that to the second power. I can figure out what 2 to the third is. 2 times 2 times 2. That's 8. Then I have 8 squared. What's 8 squared? 64. Okay, so that's what we're doing here. That's what's happening. Okay, can we go to the next one? Okay. The next one is the power of a product. The power of a product. So what is happening here is I have 2 variables, A and B, being multiplied together. Then I have that being raised to the nth power. Now, this is not the distributive property. This is not the distributive property. But students sometimes think about it like the distributive property. So what you've got to do is you've got to give the exponent to everything inside the parentheses. Okay? So you've got to give the exponent to everything inside the parentheses. Okay, now, a mistake that students often make is they forget to give the exponent to the number. I don't know why we forget, but we do. We forget to give the exponent to the number. So for this one right here, I've got 2x, and all of that is being raised to the third power. What that means is 2 to the third power and x to the third power. That 3 belongs to the 2, and the 3 belongs to the x. Okay, can I figure out what 2 to the third power is? 2 times 2 times 2 is 8. So I have 8x to the third power. Okay. Can I go to the next one? Okay. This is a quotient of powers. We talked about product of powers. Now we're talking about the quotient of powers. The word quotient means division. Okay? The word quotient is the answer to a division problem. For some reason, we remember... I get too close to that. Okay, I'm going to rewrite that. So the word quotient means we're talking about division. Okay? We remember that a product is a multiplication problem, but we forget that quotient is a division problem. Okay? So quotient means division. So when I am dividing exponents with the same base, I subtract their exponents. Now they have to have the same base, but when I do that, I subtract. So if I've got b to the n power over b to the m power, then I do b to the n minus m. Okay? So let's think about what this x to the fourth over x squared means. Let's think about what it means. Okay? X to the fourth means x times x times x times x. It's x multiplied by itself 4 times. X squared means x times x. Now, if we have something on the bottom and we have something on the top, what can I do? Cancel it out. Okay? So I am left with x squared. And that's x squared over 1. Do I have to write the 1? No, I don't have to write the 1. Okay? So it's x squared. Okay? So using our property here, 2 to the 5th divided by 2 to the 2nd, that means 2 to the 5th minus 2, and that's 2 to the 3rd. Okay? What's 2 to the 3rd? It's 8. Okay? Now I can figure out what 2 to the 5th is. 2 to the 5th is 32. 2 to the 2nd is 4. Is 32 divided by 4 8? It is. Can I go to the next screen? Okay. Okay. So what I have here is I have 3x squared times y, and I am multiplying that times 4x to the 3rd y squared. 3x squared times y, and I am multiplying that times 4x to the 3rd y squared. Okay? So, the first thing that I am going to ask myself when I'm doing this is there an exponent on the outside of the parentheses? So look for an exponent. Okay, and if there was an exponent on the outside of the parentheses, that means that exponent would belong to everything inside the parentheses. Okay, I don't have that here. Okay, so there's nothing on the outside of the parentheses that belongs to everything on the inside. So I'm good. So the next thing that I'm going to do is I'm going to multiply my numbers together. Okay? I am multiplying my numbers, and by that I mean my coefficients. So I multiply the coefficients together. Okay? So I have 3 times 4. What is 3 times 4? 12. Okay? Then the next thing I do is I multiply my x's together. Okay? So here I've got x squared times x to the 3rd. Okay? X squared times x to the 3rd. What does that give me? X to the 5th. I add them together. So I have x to the 5th. Okay, then I multiply my y's. Okay. Now, if I had y, what coefficient is in front of that y? 1. So y is the same thing as 1y. And I don't have to write that 1. Okay? When I have y, I also have an assumed exponent of 1 that I don't have to write. But when I am multiplying these together, I am multiplying y to the first power times y to the second power. So I end up with y to the third power. Okay? So just remember, if you've got a variable and there is no exponent written with that variable, then that variable is raised to the first power. Okay? Can I go to the next one? Okay. Here I have negative 5, a to the third times b to the fourth. All of that's inside parentheses. And I am multiplying that times 7a squared b to the fifth. Okay? So the first thing that I'm going to look at are my numbers, my coefficients. So I have negative 5 times 7. What is negative 5 times 7? Negative 35. Okay? The next thing that I'm going to look at are my a's. So I have a to the third times a squared. And a to the third times a squared is a to the fifth. Good. Then I have b to the fourth times b to the fifth. And that is going to give me b to the ninth. Okay. Can I go to the next slide? Okay. I know we don't like fractions. It's the same idea. We're going to multiply our coefficients together first because I don't have anything on the outside of those parentheses. So I have 3/4 times 1/2. Okay. I can't cross cancel anything here. So I just multiply the top and then I multiply the bottom. I do not need, excuse me, thank you. I do not need a common denominator because I'm multiplying. Okay? 4 times 2 is 8. So I have 3/4. Then I have x to the first, because when there's an exponent not written, there's a 1 there, times x to the fifth. That gives me x to the sixth. Then I have y to the first. Again, when there's not an exponent written, we write in a 1. And then I have y to the sixth. So that is y to the seventh power. Are we ready to move on to the next type of problem? Okay. So this problem right here, the problem right here is x to the second times y to the third, and all of that is being raised to the fourth power. Now, for this type of problem, we are combining two different properties. We have a power to a power property, okay? Okay, whoops, where are we? There we are. Power to a power. So that's the property that we're using. So when I have an exponent raised to another exponent, I multiply those together. But we also have the power of a product property. So we are using two properties at the same time with the type of problem that we're doing here. Okay? So I've got to do a power of a power, or a power to a power. What that means is I give the exponent to everything inside the parentheses. Then I've got, I'm sorry. The power of a power property means I multiply. And you don't have to be able to label the different properties that you're using. But what the power to a power property tells me is that x squared risen to the fourth power is going to be x 2 times 4. That's what the power to a power property tells me. Okay? The power of a product property, that's the one that tells me I give the exponent to everything inside. Okay? So we want to make sure we've got that straight. And I'm the one that messed it up first. But that's what that means. Okay? So I've got to give that 4 to everything inside the parentheses. And when I do, and it's raised to an exponent, that's when I multiply. So I have x to the 2 times 4, and then I have y to the 3 times 4. Okay? So I have x to the 8th times y to the 12th. Okay? Okay. Here I have 3a to the 5th. Remember that 3 belongs to everything inside that parenthesis. So I am going to have 3 to the 3rd power, and I'm going to have a to the 5th power times 3. And one of the things that students forget is they forget to give that 3 to the numbers, the coefficients. I don't know why we forget, but we do. Okay? So I've got 3 to the 3rd power. That's 3 times 3 times 3, which is 27. And that's 27a to the 15th power. Okay? Can I go to the next one? Okay. Now, we're using those same 2 properties again. Students, whenever, this is another place that students make mistakes, is they mess up the negative sign. I want you to get in the habit of writing that -2 inside parentheses, because the negative and the 2 is being raised to the 5th power. The negative and the 2 is being raised to the 5th power. Okay? And in this situation, when we raise a negative number to an odd exponent, we get a negative number. But if I raise a negative number to an even exponent, what do I get? A positive number. Okay? So you want to be careful with that. Okay? Then I have x to the 1st power times 5, because x to the 1st is being raised to the 5th power, so I multiply the exponents. Then I have y to the 4th power times 5. Okay? -2 to the 5th power is -32. That's just -2 times -2 times -2 5 times. Okay? And I do get a negative number when I multiply it times it, or I'm raising it to an odd exponent. Then I have x to the 5th and y to the 20th. Okay? Can I go to the next one? Okay, this is our quotient of powers. And we're going to do something very similar here that we did with product of powers. The first thing that we're going to do is we are going to divide the coefficients. And the coefficients are those numbers in front of those variables. So I am dividing the coefficients. Okay? 24 divided by 3 is 8. Okay? Then I am going to use the subtract, which the quotient property allows me to do that. And I am subtracting exponents in order to divide the variable. Okay? So what I'm going to have is x to the 5th minus 2. And that leaves me x to the 3rd. Okay? So, now my next one. Negative 56, x to the 9th.
Can you go back?
There you go. You good? Okay. Our next one has a negative number divided by a positive number. I'm going to deal with that first. I'm going to deal with the negative 56 divided by 7. Negative 56 divided by 7. Okay? Negative 56 divided by 7 is negative 8. Okay? Now, I told this to the last class and they kind of laughed. Okay? 7 times 8 is 56. Sometimes we always forget that multiplication fact. I always have to stop and think about it. So it's 7 times 8 is going to give you 56. Okay, the other multiplication fact that we forget is 9 times 6 is 54. Students get the 56 and the 54 mixed up. So if you're ever not sure if it's 54 or 56, think 5, 6, 7, 8. 7 times 8 is 56. You guys aren't nearly as amused as my last class. They were all like, oh, wow. Yeah. When my daughter was in 4th grade, I told her that trick, and she wanted us to keep it just between ourselves. She didn't want me to tell anybody else. And I said, honey, I didn't come up with this. Someone way smarter than me came up with that. Anyway. Okay, so let's get back to exponents. Okay, then I have x to the 9th divided by x to the 4th. So the way that we do that is x to the 9 minus 4. So I am left with x to the 5th. Okay? So that is quotient of powers. Okay, can I go to the next screen? Okay. Again, we've got numbers that we've got to deal with first. I have 48 divided by negative 12. That 48 divided by negative 12 is negative 4. So I deal with those coefficients. Then I have y to the 7th divided by y to the 1st. So don't forget that y in the denominator has a 1 associated with it. And so then I have 7 minus 1, and that gives me y to the 6th. Okay? So that brings us to the conclusion of our properties of exponents. And again, this week what we're doing is we're putting everything together. We're putting everything together because next week we're going to start taking everything apart. So the directions for what we're doing this week would be simplify. We're simplifying everything. We're putting everything together. What we're going to do now is we are going to start taking monomials and binomials, and we are going to start multiplying those times binomials and trinomials. And so all of these properties that we used when we were multiplying, dividing monomials is essentially what we were doing. We're going to take that information and we're going to apply it for when we use a distributive property. We're going to use FOIL. We're going to start multiplying these even more. Now, last chapter, you might have come across something that looked similar to 2 times 3x plus 4. What did I have to do when I had something outside the parentheses? I had to distribute it. Okay? I had to use a distributive property. So 2 times 3x is 6x. What's 2 times 4? 8. So that 2 on the outside, we had to distribute it to everything on the inside. Okay? So that is the distributive property. And we are going to use the distributive property now. Except we are going to be multiplying things together with variables that have exponents. So we're going to have to use all of those exponent properties. So I have 3x squared times 2x squared. Then I'm going to have 3x squared times 5x. And then I'm going to have 3x squared times 3. I still have to distribute that the same way that I had to distribute my 2 over here on the right-hand side. So this is going to be 3x squared times 2x squared. Okay? Then I'm going to add that to 3x squared times 5x. Then I have 3x squared times 3. And I would encourage you to go ahead and write that out even now. Go ahead and write that out so that you can make sure you keep it all clear. Okay? Now I'm going to multiply my coefficients together. I've got 3 times 2 is 6. X squared times x squared is x to the 4th. Okay? 3x squared times 5x is 15x to the 3rd. 3x squared times 3 is 9x squared. Okay? Now, if I have any like terms, and a like term means same variable raised to the same power. Okay? Same variable raised to the same power. Do I have any like terms here? I don't, because they're all raised to a different power. They're all x's, but they're still raised to a different power. Okay? Okay. Can I go to the next one? This is a binomial times a binomial. That means 2 terms times 2 terms. Okay, so a binomial times a binomial. And we see this a lot. We see 2 binomials multiplied together a lot. We are using the distributive property, but we are using a special case of the distributive property because we use it so much it's got a special name, and it's called FOIL. Okay? FOIL is still the distributive property. So I've got first, F is for first, outer, inner, and last. FOIL is one of those things that students typically remember from high school. It's just one of those things we don't forget. Okay? So I'm going to do my first terms. So I have x times y. That's my first. My outer is x times 5. My inner is 2 times y. And my last is 2 times 2. I'm sorry, 2 times 5. Okay? So I have xy plus 5x plus 2y plus 10. Now, you always ask yourself, do I have any like terms that can be combined? Always check. That's the last thing that you ask yourself when you're doing these. Do I have anything that can be combined? And I don't. Okay, I don't have anything that can be combined. Okay, so I'm done. That's my final answer. Okay. Can I go to the next screen? Okay. We're going to do FOIL again. First, outer, inner, last. 3x times 2x. Whoops, I'm going to write that out. 3x times 2x. Okay, that gives me 6x squared. 3x times negative 1. 3x times negative 1 is minus 3x. Then I have 2 times 2x. That's 4x. And then I have 2 times negative 1. Okay? I always ask myself if I have any like terms. And in this situation, I do. A lot of times, these two terms right here will be like. Okay? So I have 6x squared plus x minus 2. Okay? It's not always that those are like terms. It's just often they are like terms. So you definitely want to check. You want to check that. Okay? Can I go to the next one? Okay. 3x minus 4y, all of that is squared. Okay. Now, this is the wrong way to do this. It is the wrong way to do this. What students do is they think this means 3x squared minus 4y squared. Okay? And so they get something like 9x squared minus 16y squared. This happens all the time. Sometimes students will square the negative and they'll get 9x squared plus 16y squared. The reason that students are doing this is wrong, but the reason that students are doing this is because of this power right here, or this property right here. The power of a product. Okay? What students are remembering is if they've got an exponent on the outside of a parentheses, they give that exponent to everything on the inside of the parentheses. Okay? What operation is happening between A and B right here? What operation is that? Between A and B and between 2 and X? Multiplication. So the power of a product only works when you're doing multiplication. It only works when you're doing multiplication. What operation is happening? Oops, where am I? Here. What operation is happening between the 3x and the 4y? Subtraction. So you can't use that property here. Okay? And this, all of that is wrong. What you have to do here is you have to FOIL. And this is one of the things I write all the time in my pre-calculus class. I'm like, you've got to FOIL this. You've got to FOIL this. Okay? So what I'm doing here is I've got 3x minus 4y times 3x minus 4y. Okay? That's what that means. And I would write it out. Because if you don't write it out, you're in danger of doing this over here. Okay? So this means 3x times 3x. Okay, that's 9x squared. Then I have 3x times negative 4y. 3x times negative 4y. Okay, that's negative 12xy. Then I have negative 4y times 3x. Okay, negative 4 times 3 is negative 12. Y times x is yx. Okay, is y times x the same exact thing as x times y? Okay, think about 2 times 3. What's 2 times 3? What's 3 times 2? 6. So could I write that? The important thing here is that you recognize that these are like terms. This minus 12xy and this minus 12xy, whether you have it written xy or yx, they're still like terms. Okay? And then my last one, I'm going to erase this so that I have enough room. My last one is I have negative 4y times negative 4y. Okay, and that gives me positive 16y squared. Okay, you always want to look and see if you've got any like terms. And I do have some like terms. So I have 9x squared minus 24xy plus 16y squared. Okay, can I go to the next one? Oh, I didn't think I wrote it down. Okay. The next one is 3a minus 2b times 3a plus 2b. Now, this is something that's called the difference of perfect squares. And that is going to be super important when we factor. Okay? Difference of perfect squares. It is most important when we factor, but it's a good idea to start being able to identify that now. Difference of perfect squares. Okay? We are still going to FOIL this. We're still going to FOIL this. So I have 3a times 3a. That is 9a squared. I have 3a times 2b. That is positive 6ab. Now my next one, I have negative 2b times positive 3a. They are going to be like terms, but one is positive 6 and one is negative 6. So what's going to happen to those two middle terms? They're going to cancel out. Okay, that's what happens with difference of perfect squares. Then I have negative 2b times positive 2b. So that's negative 4b squared. In the difference of perfect squares, those in the middle always cancel out. And I'm left with 9a squared minus 4b squared. Now, it's not imperative that you identify 3a minus 2b times 3a plus 2b as difference of perfect squares. But what you'll notice is you've got your 3a and your 2b, and you've got subtraction here. Then you've got 3a and 2b, and you've got addition here. That's what makes it difference of perfect squares. What you're going to have to do when we start factoring is you're going to have to be able to identify 9a squared minus 4b squared as a special case. So when we are putting it all together, when we're doing all the multiplication, I like to bring that up. Okay? Okay. Questions? Okay. So